Alright, so let's look at the derivatives of exponential functions. So what do we mean by exponential functions? Basically, we are saying that when we have something like a raised to the power of x, b to the power of y, these functions are exponential functions because they are raised to the power of something, right? Another number, basically. So now we are going to be deriving exponential functions. So very quickly, we have something like y e to the power of x. Now this e is representing Euler's number. This e is it's very common when we deal with things like logarithm, when we deal with derivative or exponential function. It is very, very common, or even integration, right? So now for this e is Euler's number. So now um to differentiate something like this, we have to first level it, because very quickly now you can see that x here is the power of e, but we are looking for the derivative of y with respect to x, right? The y dx, which means that we are differentiating x. So very quickly, what we're going to do is that we're going to level this so that x is on the ground, right? So we just let everything be in this. So we can do that by adding ln, right? Ln means natural log. So we say lny, you have to add it to both sides, right? Ln e raised to the power of x. Now ln works the same way log does, right? So whenever you have something like this, log b to the power of a, it is equal to a log b. That's the same way ln works. So if you have natural log of b to the power of a, it is still a natural log of b. This is equal to this, and this is equal to this. So now what's the relationship between normal log and natural log, right? So ln of a is equal to the natural log e of a. This is what it means. The natural log of a is just equal to log e of a. So keep this in mind, very important. So now for this question, so let us simplify further. Ln y will be equal to x ln e. So now e is on its own. So what we are going to do now, we are going to find the derivative of both sides, right? Remember I said that whenever you derive for y, you have to add dy dx, right? So we're going to derive for y. So we have ln y. Whenever you derive something such as ln of an alphabet, so let's say x, it is equal to 1 over x. The derivative of ln x is 1 over x. So that means the derivative of ln y will be 1 over y. That's simple. So this is going to be 1 over y, but we're not going to just end here. We're going to add our dy dx because we are defining the derivative of y, right? Then for this x, we have x and natural log e. Now what you need to understand is that for ln e in this scenario is the coefficient of x. We're only differentiating x, so any other thing with x is the coefficient of x, right? So when we differentiate x, we just get 1, right? We get 1, which will be ln e, natural log of e. So from here now we're going to make dy dx of the formula, right? So cross multiply. So we're having dy dx is equal to y log e. Y log e. So now dy dx is y. Now what is y? Y is e to the power of x. So we're going to replace it, right? Because our answer should not have y in it, right? Our answer should have something that has x in it. So we're going to replace y with e to the power of x. So we're going to put e to the power of x. Then we're going to have ln e. So now this could be our answer, but we can still simplify further. Now this ln e, the natural log of e is equal to 1. The natural log of e is equal to 1, right? So now remember when I did something like this, right? I said that ln a is equal to log base e a, right? So now we're saying ln e, that's going to be equal to what? Log base e e, right? Because this a came here, so that means this e also has to come here. And according to the laws of logarithm, whenever the base and the number are the same, it is automatically equal to 1. So that means ln e, or the natural log of e, is equal to 1. So we can say e to the power of x times 1, and this is going to give us e to the power of x, right? So whenever they ask you to find the derivative of e to the power of x, it is just still going to be e to the power of x. But this is how to get it. So we have proved that it is actually e to the power of x, right? So even if they ask you find the 100y over the x 100, that means you should find the 100 derivative of e to the power of x. It is still going to be e to the power of x. No matter even 1 billion, it will always still give you e to the power of x. So just understand this concept, because that's what we use for most of these questions when we deal with exponential functions. So let's go to question 1 very quickly. Now that we've understood the basics of exponential functions, we can just go to questions and start solving. Alright, so for question 1 now, we have y is equal to e to the power of 2x. So very quickly, we want to make it leveled so that x is on a level ground and not as a power. So we add the natural log to both sides. So natural log of y is equal to the natural log of e to the power of 2x. Then we have natural log of y equals to 2x, the natural log of e, right? So now we're going to find the derivative of both sides. We'll derive y, which will give ln natural log of y, which will give us 1 over y. Then we're going to multiply this by dy dx. Don't forget, whenever you differentiate y, you add dy dx. Then we differentiate 2x natural log of e, right? So now 2x, when we differentiate 2x, we're going to get just 2. So we have 2 multiplied by the natural log of e. And so here we're going to have dy over dx is equal to 2y, the natural log of e. And we already know that the natural log of e is what? Is equal to 1. We have proved that. And now y is equal to 2 e to the power of 2x. So we're going to replace that. So that will be 2 times e to the power of 2x times 1. So our final answer will be 2 e to the power of 2x. Now this is how to get your answer. Although we could just do something very quickly because of time. You have e to the power of 2x. Whenever you are faced with something like this, just differentiate this 2x here. When you differentiate that, you get 2, multiply it with e to the power of 2x, so you're going to have 2 e to the power of 2x, and you can see it's the same thing. This one is just shorter. This one is showing you the steps to prove that what you're actually doing is correct. So very quickly, whenever you get an exponential function that e is the base, right? Whenever you get exponential function that e is the base, when e is the base, you just differentiate the power 2x, and then you get 2, and then you multiply it with the exponential function itself. So let's clean this and proceed. So question 2. So for question 2 now, we have y is equal to x squared e to the power of x. X squared e to the power of x. So now this one now, we are not just having e to the power of x, we have another number, right? So x squared is multiplying ex. Remember, when two things are multiplying, we use product rule. So that means we're going to be using product rule for this. So we're going to say let u equal to x squared and let v equal to e to the power of x. Now very quickly, our formula for product rule is u the v dx plus v du dx. Now we have u, we have v, we need to find the v dx and we need to find the u dx, right? So now for du dx, that's going to be equal to 2x, and now for dv dx, that's just going to be equal to e to the power of x, right? We have already done this before in the beginning part of the video. Just to reiterate what I said, you will just differentiate x, the value of the power here, which is x, that will give us 1. So 1 multiplied by this function and you get this. Or you go the normal method, you take the ln of both sides, then you solve. So but basically we have gotten u, v, dy, du dx and dv dx. So now let us solve. So that means our dy dx is equal to u, which is x squared, multiplied by dv dx, which is e to the power of x, plus v, which is e to the power of x, multiplied by du dx, which is 2x, right? So we're going to be having x squared e to the power of x plus 2x e to the power of x. This could be your answer, but ex is common, so let us factorize it out. So we have x squared plus 2x, and this is our final answer for question 2. So very simple stuff. Let's just go straight ahead to question 3. You can pause the video at any time if you want to write. So for question 3 now, we have something that looks to be complex, but it is still very easy. We have y e is equal to e to the power of tan x. Y e to the power of tan x. Remember, you just differentiate what you have here. Remember from the videos we did yesterday on derivatives of trig functions, when you find the derivative of tan, right, when y is equal to tan x, and the y dx of tan x is equal to sec square x. If you don't know how we got this, go and watch the video, I explained it. Remember, tan x is equal to sine x over cos x, and it's going to be u, this v, and you're going to be using the quotient rule. You can watch the video and you see there's also a separate video on quotient rule. You can also go ahead and watch that, right? So now I said that you're going to just differentiate this and then you multiply the derivative by the entire function. So that means our dy dx is going to be equal to sec square x multiplied by e to the tan x, right? So our final answer is sec square x e to the power of tan x. So see, very, very simple. There's nothing really difficult about exponential function. All right, you can pause the video at any time to write down. So let's go for question 4 now. Question 4. So for question 4, we have y is equal to e to the power of minus x ln x, all right, or natural log of x. So here now, it is also multiplying. So we have ln x multiplying ax. So that means we can say our u is equal to e to the power of minus x, and our v is equal to ln x. Now we're going to be using product rule. So our product rule formula is u dv dx plus v du dx, right? Okay, so now let's find our du dx. Our du dx will be equal to, here we're going to have, just find the derivative of this. That'll be minus 1. So we'll have minus 1 multiplied by the entire function. So that'll be minus e to the power of minus x. Then we're going to have dv dx. When we find the derivative of ln x, we get 1 over x. I already explained this at the beginning of the video. So now let's find out dy dx, which will be u, which is e to the power of minus x, multiplied by dv dx, which is 1 over x. Yes, then we have plus our v, which is ln x, then multiplied by du dx, which will be minus e to the power of minus x. Now, e to the power of minus x is going to be equal to 1 over e to the power of x. Remember from the laws of indices that we have, when a is to the power of minus 1, it is 1 over a. If it's raised to the power of minus 2, is 1 over a squared. So the same thing applies for even Euler's number. So we have 1 over e to the x multiplied by x that we have here, then plus, we have here, we're going to be having minus e to the power of minus x. That will be 1 over minus e to the power of x. So we'll be having ln x over minus e to the power of x. And simplifying this, we're going to be having 1 over x e to the power of x minus the natural log of x over e to the power of x. We can still simplify this further by changing into one fraction, but we are good to go with this. So let us move down to question 5. Question 5 now is a little bit trickier, because this one now we are not having Euler's number, we're not having e, right? We're having something different from e. So that is why it was very important that I explained how to actually get derivative of a special function at the beginning of the video. Once you can get that, then the rest is easy, because you cannot apply that method for this one, right? You cannot apply that method for e for this one, right? You have to apply the one we did at the beginning of the video. So very quickly, we're going to take the natural logs of both sides. So ln y, the natural log of y, is equal to the natural log of 5 to the power of x. So we're going to say the natural log of y is equal to x, the natural log of 5. Then we're going to derive both sides. So here we're going to have 1 over y multiplied by the dy dx is equal to, well, here now, lateral log of 5 is a constant, or is the coefficient of x. So we're just going to differentiate x, because this one is a constant. Just like when you have 2x, right? This 2 is representing ln 5. And when you differentiate this, you get what? Just 2. So when you differentiate x, natural log of 5, you get just natural log of 5. So here now we're going to have dy over dx is equal to y times the natural log of 5. Now what is y? Y is 5 is to the power of x. So we're going to say 5 to the power of x multiplied by natural log of 5. And this is our final answer. Very, very simple stuff. Very, very simple. The first thing you just need to do is to take the natural log of both sides. Right? Take the natural log of both sides, then level the equation. What I mean by level the equation is by bringing this power of x, bringing it to the back of the natural log. And once you do that, then you take the derivative of both sides. When you take the derivative of both sides, and then you solve, and the rest is history. Very, very simple. Then we go to question 10, which is the last one. You can pause the video to try out question 10. Then you can come back and check if your answer is correct. So let's go for question 6 now, our last question. So we have y is equal to 10 to the power of 2x. So now for this, now what I'm going to do, we just take the natural log of both sides. So we have the natural log of 10 to the power of 2x, and here we're going to have natural log of y is equal to 2x natural log of 10. Then we'll take the derivative of both sides. Then this will be multiplied by the y over the x is equal to 2 natural log of 10, right? Because this 2 and natural log of 10 is a constant, right? It is the coefficient of x, right? So whenever we differentiate this, we're just going to get 2 ln 10. It's just like something like if you add 2x squared ln 10, we're going to differentiate x squared, and then we're going to get 2x, then we'll multiply everything. That will be 4x natural log of 10. Hope you understand this. So now we're going to say the y dx is equal to 2y natural log of 10. So what is y? Y is 10 to the power of 2x. So that will be 2 multiplied by 10 to the power of 2x multiplied by ln 10, or natural log of 10. And this is our final answer. There's nothing much you can do from this point. Although your answer might not look in this form, it might look something like this: 2 log, okay, sorry, not log. Okay, we have 2 into the bracket 10 to the power of 2x. Then we can have log base e 10. Remember I said at the beginning of the video that when we have ln a, it is equal to the log of to base e of a. This is equal to this. So if we have ln 10, it's going to be log to the base of e, then 10. So your answer could be in any of these form. The same thing for all the other questions that we solved. It could have log, or it could have natural log. So depending on the taste of the lecturer. If the lecturer wants log, then you should be able to convert it. Just have this at the back of your mind. This conversion, have it at the back of your mind. Then, but always solve in this limit, because most lecturers will use natural log instead of log, right? So if they use natural log, then this, you will see your answer in this form. If they do not, then your answer will be in this form.